Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the word search problem. Given an n by n grid of characters board and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighbouring. The same letter cell may not be used more than once. So if we're looking for A, B, C, C, E, D, A, B, C, C, E, D. Okay, that makes sense. Here we're looking for the word C, S, E, E. Cool, we could have tried going up here, S, E, but we quickly ran out of space. And here A, B, C, B. We can see A, B, C, B, but that would reuse a letter on the board, so it does not count. I am almost certainly sure I've solved one like this. I don't know if I've released the video for it yet. I can't remember. It was a variant on this where you weren't just trying to find one word, you were trying to find many words within the board. That was hard. That was a very hard problem. I think this one is a slightly simpler variant. And the way it works basically is we want to do a search. Where first I need to find the A, and then I want to look at its neighbors and find the B, and then I want to look at its neighbors and find a C, and so on and so forth. And basically I just want to do a search like that. I don't think it matters too much what kind of search I do, as long as I do a search. So, you know what, let's do a breadth first. No, let's do a depth first search. Just because I think it will be easier. So basically self.board is equal to board. Let's do stack is a list containing, well, let's how do I want to do this? I don't quite know where I want to start. Okay, so the start is going to be a little bit funky. So let's do self.startState word. And then while stack next state is stack.pop. I need a scene set. Scene is equal to the set if state in scene continue scene.add state. Oops, I need to do one up here. If self.is goal of the state, return true. And I want to return false if I never do that. Oops. And for next state in self.extend state stack.append next state. Right. This, if you've watched any of the previous videos, is a graph search. Usually on this channel we seem to be coding up with a breadth first search. We could probably do this with a breadth first search. That would be absolutely fine. But I've decided to do it with a depth first search. The difference between a breadth first search and a depth first search is normally, if for a breadth first search, I would be using a queue here. So I'd be putting things onto the queue and taking them off the queue when I'm deciding to expand that state. Here, I'm using a stack. So when I push things onto the stack, they're almost immediately going to come off again, because that's how a stack works. And what that means is, whereas a queue likes to try and keep all of the states of approximately the same size, because you put all of the one states on and you take all the one states off, and you put all the two states on and you take all the two states off. Whereas this one likes to explore a state as fully as it can before trying something else. So it'll go zoom, 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 zoom as far as it can before it starts coming back. I don't know if that's the appropriate way to do this, but it is a way to do this. We do need a couple of helper things here. We need a start state, we need an isGoal, and we need an extend. And I'm not quite sure what I want my state to look like. I guess the state can be the coordinates we've used. That makes sense. So in fact, let's do this with start states. Let's do self.word as well, so I don't need to pass word around. So the start states are any location in the board that has a that starts with the same letter as the word. So states is going to be an empty list. For I in range len self.board. In fact, this is row for call in range len self.board 0. If self.board row call equals self.word 0. So if this is the right letter, states.append, let's do row column. That looks like a lot of parentheses. What it is it's a tuple with a single element, which is a tuple containing the row and column. So this is going to be a tuple of pairs. If you've seen me code these before, you'll know that I like storing these things in tuples because tuples are immutable. So that means if I manipulate a state to produce the next state, I don't break something that I'm currently working on, which can be a bit of a danger in Python if I was to use something like lists. And then I want to return states. So that gives me my stack, effectively, of starting states. So here we'll probably start at this one, because I'd see that one second. So it would go onto my states second. But there's no point worrying about that, because either of them are potential starting points. isGoal state return len state is equal to len self.word. So if we have taken 1, 2, 3, 4, 5, 6 cells, 1, 2, 3, 4, 5, 6 cells, then we are done. We could do a check here around each position, but we don't really need to, because we'll make sure that our extend doesn't let us take a bad step. So what we want to do is the head is, in fact, let's do row call is state -1. So the last thing we looked at, if we were here, this would be 0, 1, 2, 0, 1, 2. This would be the 2, 2 column. Row is 2, column is 2. This would say where we are now. So what we want to do is options is equal to, well, we can move adjacent. So adjacent means no, horizontally or vertically. Sorry, yeah, I was gonna say, does adjacent mean diagonal? No, we're not allowed to move diagonally here. So options is row row +1 call, row -1 call, row call +1, row call -1. We want to return RC for RC in options if R is greater than or equal to 0 and R is less than len self.board. So that's our first condition. I don't actually need that. And C is greater than or equal to 0, and C is less than len self.board 0. So these two checks make sure we don't go out of bounds. But we also need to make sure the board position there is the letter we're looking for. So if we are, that's self.word len state minus, yeah, len state. So if we're looking to loud motorbike, if we're looking to extend, if we're here 0, 1, 2, 3, 4, so this is a fourth cell in our state, but it's a state of length 5. So we need to look in the word 0, 1, 2, 3, 4, 5 at position 5 and check that that is what we're stepping into. So these conditions all together, well, these first two just make sure that the state we're looking at is even valid. And the third one is making sure that the state we're going into is going to actually take us towards our goal. Right. I think that works. As usual, I can almost never write a graph search right on the first go, so we're going to have to run some tests, I think, just to make sure I haven't mucked anything up. There we go. Cannot... Oh, I know what it is. I need to build new states. So it's the old state with the new row and column thrown onto it. So that was a bit of a trap. Okay, so this looks like it worked. I was able to successfully weave my way through and find the word in the graph, in the matrix. This time though, I was not. I said true, true, true. I should have said true, true, false. Ah, but there's a condition, isn't there, that I didn't check. And the condition is the same letter cell may not be used more than once. So here, this is where we found our A, B, C, B. We did that. We're not allowed to do that. So we also need to do and RC not in state. We'll do that check absolutely last because it's the most expensive check. Let's try again. Excellent. Right, I think that is most of the edge cases. These things are never going to get super long or super large. In fact, they're going to be absolutely tiny. I think the hard version let them be much, much larger, like 40 by 40. Let's submit. See what happens. Is it too slow? It seems to be taking a while, or is that just the Leetcode servers? Too slow. Well, we can special case this one. To a certain extent. Because there's no B's in this board. How can we do better? I'm just trying to think what's the right way to do this. So one way is we can special case it and say, look, that letter is simply not in the board. Most generally, it's really hard to know whether we're on the right track or not. You know what, let's special case it. All letters, board letters. The board letters is the set containing L for row in board for L in row. Word letters is set word. If not, now which way around does this subset thing go? Word letters dot sub is subset. Let me just copy this case. I want to print board letters word letters dot is subset board letters. I cannot even remember if it's called is subset, but it's worth a go. It doesn't have an underscore. Why not? Nobody knows. Well, that's correct. That's the board letters, that's the word letters. A, B is not a subset of A, because it has a thing that does not exist in this set. It has a B, so therefore that's the correct rejection. Is that too much of a special case? Let's find out. Apparently that was fast enough now. Excellent. It's not super fast. Probably a more clever search. Maybe this is not the most efficient way we can manage the state. And breadth first search might have been more efficient. Who knows? Anyway, that is the problem, I suppose. I don't love this hack here, but it works. Again, we could change this for another kind of search, like a breadth first search, perhaps. I don't mind this. I don't mind this, although we could be more robust and make this actually check that the state corresponds to the word. And here, this is the one that's kind of doing the magic. This is making sure that we're moving to somewhere that's valid, that has the right letter, and doesn't let us do any repetitions. If we did this inside is goal, what could happen is we end up just adding a lot of states to our search that are invalid. And that's not a problem. We would reject them eventually if we had a more complete is goal, but if they're never in our search to begin with, we don't then have to expand them, which saves time. Anyway, I think that'll do it. I just had a sudden mind blank there. I was going to say something and I don't know what it was. So it can't have been that important. So if you know what I was going to say, do let me know down in the comments. Remember to like, comment, subscribe, all of that good stuff. And I will see you next time. Bye.